In this video, we're going to learn about the activity series through some simulations. So we have four beakers here, each with a nitrate solution of a metal. So magnesium nitrate, zinc nitrate, copper 2 nitrate, and silver nitrate. And what we'll do is we'll take a piece of magnesium and drop the piece of magnesium into each of these. Now, in the case of the magnesium nitrate, when you have magnesium cations bouncing into a chunk of magnesium, nothing really happens. There can't be a single replacement of a metal by the same metal's cation. But in the case of the zinc 2 nitrate, notice that the zinc 2 cations approach the piece of magnesium metal, and as they collide with the magnesium gives two electrons to the zinc, and the zinc goes from being positive to being neutral. This is now solid magnesium metal, and it's replacing the magnesium, which goes off as positive 2 cations that balance out the charge in the aqueous solution. Similarly, if we have copper 2 ions and copper 2 nitrate, they will approach the magnesium metal and undergo this electron transfer where the magnesium gives two electrons to the copper, and the copper reduces to copper metal. So what we can see as we remove the piece of metal that we inserted into each of these solutions is that, well, nothing really happened with the magnesium nitrate, but the zinc actually plated onto the surface of the magnesium. And here we have the copper plating onto the surface of the magnesium. And yes, over here as well, silver was plated onto the surface of the magnesium in that reaction. If we were to replace, let's go with instead, let's use, say, copper. Well, if we put a piece of copper in, the copper is not actually able to react with the magnesium, because magnesium, again, it's very stable in the positive 2 state. Copper is actually not as stable in a positive state. And so copper is not going to give its electrons to the magnesium. Remember, copper is pretty far to the right of the transition metals. Its reactivity is rather low, and we can see that here. It's not reacting with the magnesium. On the other hand, the copper will react with the silver because silver is even less active than copper. And so, as two silver ions approach a copper atom, the copper atom gives each silver ion an electron, and those silver ions go from positive to neutral, and the copper goes away into aqueous solution as copper positive 2. And for this reason, we can see that the copper metal was completely untouched when mixed with magnesium and zinc uh, ions, which are more active. Copper, of course, wouldn't displace copper. But we did get plating of silver onto the piece of copper in the case of the silver nitrate solution. Finally, I just want to show this is exactly the same concept, but we're going to have some hydrochloric acid, and we're going to see what happens when metals are put into hydrochloric acid. So zinc is a fairly active metal, so is nickel and iron. If I put a piece of iron into some hydrochloric acid, what we can see is that the hydrochloric acid went from being clear to being somewhat colored. We can see it's kind of greenish here, and that's because the iron oxidized. It went from being neutral to being positive 2, and that's because the hydrogen was less active than the iron. The iron oxidized, and the hydrogen went from being positive to being neutral. And hydrogen in the neutral state is this H2 gas. That's the reason why we were able to see some bubbling occurring. And if I remove the piece of metal, note that it got smaller because the iron metal that was there, it dissolved partially. Now, on the other hand, if I take some copper and put that into my HCl, copper is a less active metal, and you can see this copper is not changing. It's not getting smaller. We're not seeing any bubbles. But if I go to the molecular scale, we can understand why. The H plus ions just bounce right off because hydrogen is actually more active than copper. It's higher on the activity series, and the copper simply is unchanged. It does not give up its electrons to become positive and go into solution. So that's all for this video. I hope it's been helpful. Feel free to leave any questions or comments in the comments section below, and thanks for watching.